Alright, so today we're going to start exact values, and when we start exact values you need to review your special right triangles. So the first special right triangle, let's do the 30, 60, 90. So if this is 30 degrees, this is the 60 and the 90, we say x root 3, and 2x. And then for the 45, 45, 90, it's x, and root 2. Now, before we start though, rather than saying x, we're going to get some true ratios, so I don't want to use x, but I need to keep the ratios consistent. So let's just let x equal 1. So if you just plug in a 1 everywhere you see an x, then this is 1 root 3. This is just 1. This is just 2. So now across the 30 is 1, across the 60 is root 3, across the 90 is 2. Same thing with the 45, 45. This is 1, 1, and, oh, I'm sorry, I left out my x here, so now it's 1 root 2. Alright, so this is the first thing. It's just you have to assume that x is 1 here. We've already talked about how you can label your unit circle. If you go around the circle, then this is 30 degrees, which is pi over 6. This is 2 pi over 6, which reduces to pi over 3. This is 3 pi over 6. Notice that I'm skipping the 45s because it's easier if you just do all the 30s at once and then do all the 45s. So this is 3 pi over 6, which is pi over 2. This is 4 pi over 6, which is 2 pi over 3. 5 pi over 6, which does not reduce. This is 6 pi over 6, which is just pi. Uh, 7 pi over 6. 8 pi over 6, which is 4 pi over 3. 9 pi over 6, which is 3 pi over 2. 10 pi over 6, which is 5 pi over 3. 11 pi over 6. And this is 2 pi. And I guess I should have started at 0. Alright, let's do the 45s before we continue. So all the 45s, again, we should get in the habit of starting at 0, and then we go to the first 45. So the first 45 is 1 pi over 4. Remember, when you add 45 and 45, you get to the 90. So this is 2 pi over 4, but that still reduces to pi over 2. So this is 3 pi over 4. This is 4 pi over 4, which is still pi. This is 5 pi over 4. This is 6 pi over 4. And this is 7 pi over 4. And this is 8 pi over 4, which is still 2 pi. Okay, all of that should be really review. So with the unit circle, you're using this circle and you're going to use your special right triangles at the same time. So let's do our first example. So 7 pi over 6. So what we do is you say, okay, we're going to use the unit circle to find the 6 trig functions of the given angle. So 7 pi over 6, if you look at your unit circle, is right here. So you connect that 7 pi over 6 to your x-axis, and you can form a triangle. Now this triangle, so here's where my 7 pi over 6 is. I connect, and I have this triangle. So this triangle, keep in mind that if this is 7 pi over 6, this is 6 pi over 6, then my reference angle right here is pi over 6. And pi over 6 is a 30-degree angle. That should just be something that you know at this point. So if this is 30 degrees, across the 30 is 1, across the 60 is root 3, and across the 90 is 2. Okay? So once again, I might suggest, rather than coming up here and like redrawing each triangle, is when you're given a problem like this, say, okay, well, where is 7 pi over 6? So kind of think to yourself, this is 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. This is 7 pi over 6. So now draw that triangle. I know we just talked about this. I'm just kind of showing you how you should do this when you're doing it. If this is 7 pi over 6 and this is 6 pi over 6, then this is 30 degrees, pi over 6. So this is 1, root 3, and 2. So this is our triangle that we're doing, and we're going to find all 6 trig functions. So sine of 7 pi over 6 is equal to, I am really, really sorry. I don't want to go back and re-talk about all this. This is a really terrible mistake I can't believe I made. If you are going down on the y-axis, this should be -1. I should have done that up here too. If you are going down on the y-axis, this should be -1. In that same respect, if you're going left, this is negative root 3. So if you're going left here, I'm just relabeling it here as well. This is negative root 3. I am really sorry about that. Okay, so sine of 7 pi over 6 is opposite over hypotenuse, -1/2. You know, what reminded me of this, I mean, all of this stuff should come together, is all students take calculus, is what reminded me of this. And while I was working this problem, I was thinking, well, if I'm in quadrant 3, tangent is the only guy that's positive. So I knew sine had to be negative, and I was kind of figuring out what I had done wrong, and that's when I remembered I forgot my negative. So that's how all students take calculus relates back to this. Okay? All right, let's go on though. So cosine 7 pi over 6 is adjacent, which is negative root 3 over hypotenuse. Tangent 7 pi over 6 is opposite, which is -1 over adjacent, which is negative root 3. The negatives do cancel, and I will also rationalize. So root 3 over root 3. So if you notice, all students take calculus said you should expect a positive tangent. Negative over negative did indeed make positive. All right, let's keep going. So cosecant 7 pi over 6 is -2. You can either just flip this, or you can say, well, it's hypotenuse over opposite, so whichever way you want. Secant 7 pi over 6 is -2 over root 3, rationalized is -2 root 3 over 3, and cotangent cotangent 7 pi over 6 is, I'll take this original answer and flip it, so positive root 3. Alright, let's go on to another problem. Alright, so another example. Now, typically I'm not going to ask you for all 6. A typical question on a test or a quiz is just going to say, well, what's cosine of 5 pi over 3? Or what's tangent of 3 pi over 4? So let's just go through a couple of these. Let's go with cosine of 5 pi over 3. Now, this is a little bit more difficult of a problem because 5 pi over 3 is not something that perhaps you recognize when you first start off. The reason why you don't recognize it is because it does not have a denominator of 6. And when we're counting, you count by sixes. So my recommendation for this, at least while you're getting started, is say, well, 5 pi over 3, I can say is 10 pi over 6. That's going to allow me to count more easily. So this is 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6. So make your quadrant 4. If this is 10 pi over 6, or 5 pi over 3, this is 12 pi over 6, then your reference angle is 2 pi over 6, which is 60 degrees. So, I mean, honestly, you don't even have to change it back to 5 pi over 3. If 1 pi over 6 is 30 degrees, then 2 pi over 6 is 60 degrees. So that's how I knew this, is that this from 10 pi over 6 to 12 pi over 6 is 2 pi over 6, which is 60 degrees. So across a 60 is root 3. It is down, so it's negative. I'm not going to forget it twice. And then across the 30 is 1, and across the 90 is 2. So after you do that, then you can say, well, your answer is equal to adjacent over hypotenuse, so that's 1 over 2, so half. All right, tangent 3 pi over 4. So if you're doing tangent of 3 pi over 4, now I'm counting the 4s. This is just as easy to count, but on the 4s, you're going by the 45. It's actually kind of nice, the 4s go by 45. So 1 pi over 4, 2 pi over 4, 3 pi over 4. So you're in quadrant 2. If you're going by the 45s, then you have 1, 1, root 2, check for negatives. This is negative 1. And tangent is O over A, so 1 over negative 1 is negative 1. All right, let's do cosecant of 3 pi over 2. This is a quadrantal angle. These are the harder angles. If you want to think of this as 9 pi over 6, again, to get a common denominator of 6, this is 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6. So 9 pi over 6 is this angle, which doesn't really form a triangle. So you kind of have to think about this more conceptually. Cosecant is H over O. Now, we've said before that your opposite, think about any opposite on a triangle. Go back up to example A. Your opposite is like your up to downness. Your opposite is your up to downness on B. It's always your up to downness. And your hypotenuse changes, but what's going to be important is your opposite or your adjacent, in this case the opposite. And your opposite is going down 1, and down 1 represents negative 1. So the answer to this is negative 1. If you're wondering about the hypotenuse, really and truly the hypotenuse is just considered to be the distance from the origin to your ending point. And so what's really happened, okay, this is a really hard thing for me to explain on this, but in this type of example, what's really happened is you have a triangle that's so tiny, like just think of the tiniest triangle you can. It's so tiny that this hypotenuse has actually just landed itself right along the edge. So it's like the hypotenuse is equal to the opposite because you no longer have truly a triangle, right? I said that. You don't have a triangle here. It's that your hypotenuse, this hypotenuse has gotten so close to the opposite that it's just landed right on top of it. So if your opposite is -1, then your hypotenuse is still 1. Okay, this is a really hard concept, and honestly, you probably, if you're watching this video, need to come in and just ask questions about this or see if you can get it on the next day if this doesn't make sense. All right, let's do E and F now. So E and F were purposely put together because if you notice, they're both pi over 2. One's cosine and one's secant, which are reciprocals of each other. So I'm just going to draw one picture for this, and hopefully you're familiar enough with pi over 2 now. It's that 90 degree up top. So it is right there. And once again, this does not form a triangle. If you're going from the origin up, now your opposite is 1. Think about this. If you're going only from the origin up, your opposite is 1. Oops. Oh my gosh. I just don't know how to work this very well yet. I'm sorry. Your opposite is 1 because you're going up 1. You're adjacent. Think about that. If all you're doing is going from origin up, are you moving any side to side? No, you're not. So your adjacent is 0. And your hypotenuse is always 1 on the quadrantal angles. Again, it's because hypotenuse is how you have moved from the origin to where you're ending. And in this case, where you're ending is the same as your opposite. All right, so if this kind of makes sense, then answering the questions is actually pretty easy. This is the hard part to understand. But cosine is adjacent over hypotenuse, and so your adjacent is 0, and your hypotenuse is 1, and 0 over 1 reduces to 0. Now your secant is therefore hypotenuse over adjacent, which is now 1 over 0. And hopefully from Algebra 2 or somewhere you remember when you divide by 0, that's undefined. As an answer. Undefined is your answer. Okay? Alright, and that's it for this video.